So today we will move with geometric progression, the concept of the progression of geometry. So in AP we have learnt about common difference. Common difference. But in GP, okay, common difference. But in GP what we have? In GP we have common ratio. In GP it is GP, okay. GP we have common ratio. Common ratio. We got common difference by subtracting. We got common difference, then by dividing I can get common ratio. That is the concept here. Okay, so let us see how it works. Okay, right. Okay, so let AR square, AR cube, AR to the power of 4 and so on up to AR to the power of n minus 1. This is general representation of an GP. General representation of GP. This is how we represent GP generally. So here when I am dividing the second term by the first term, that is AR by A, I am getting the common ratio R. And I am dividing the third term by second term, I am getting the common ratio R. And if I am dividing the fourth term, AR to the power of 4 by third term, AR cube, again I will be getting the common ratio R. So the RS here, the RS common ratio here is R, right? Okay, now I think so this is clear for you. So this was important concept, that is the basic concept of GP. This was the basic concept of GP. Okay, now in next we will move to common ratio concept is over. Now a nth term of an GP. This is most important and dangerous concept also. Not dangerous, but it is bit to understand. Let us understand it. An is equals to AR to the power of n minus 1. It is not AR n minus 1. It is not this thing. This thing is completely wrong. It is this thing, AR to the power of n minus 1. It is AR to the power of n minus 1. Is this clear? AR to the power of n minus 1. Right. This is AN. Sorry, this is AN. So what is the nth term of an AP can be represented by AN is equals to AR to the power of n minus 1. This is the concept. AN is equals to AR to the power of n minus 1. Remember it. It may help you. It will help you. It should help you. Okay. Now sum of n terms. Sum of n terms in GP. Sum of n terms in GP. What is the sum of n terms of GP? We will see. Right. So this is also important formula. We have to remember. Sn is equals to sum of n terms of GP is equals to first term R to the power of n minus 1 by R minus 1. Remember only this formula. Actually other teachers will teach like two formulas, if R is greater than 1, if R is less than 1. That is okay, but you can remember this thing, it will cancel each other. Okay, Just remember a r to the power of n minus 1 by r minus 1. Most important formula. ar to the power of n minus 1 by r minus 1. It is not ar. Some people will write like by practicing by mouth they will say ar to the power of n minus 1 by r minus 1. This is completely false. This is the right thing, right? Okay, then this is the sum of n terms of an GP, right? Next concept, if I have an GP AR, AR square, AR, AR square, and sorry, right, and so on up to AR to the power of n minus 2, AR to the power of n minus 1. This is the last term. This is AN is last term. Right. Now in GP, if we see what if we see what? Okay, right. AR to the power of n minus 1, AR to the power of n minus 1 into A. What is this AR to the power of n minus 1? AN. AR to the power of n minus 1 into A is equal to last second term is AR to the power of n minus 2 into AR second term. This continues like last third term into the first third term. This continues. It is also followed in AP. I don't know. I have not explained that thing. I'll explain in this thing only that also. That's also important. If I have an AP, this is EP concept. Right. If I have an AP like A plus D, A plus 2D, and so on up to A plus n minus 3 into D, A n minus right, A plus n minus 2 into D, and A n minus 1 into D. This is the thing. This whole thing is in AP. This whole thing is in EP. This whole thing is in AP. Now, the first term what I am having is A. The second term is A minus 1D, that is A minus D, A minus 2D, A minus 3D, and so on like that only. Now, the thing is that like AP only, we have to not confuse here. If we will confuse, that's waste. A plus, we are doing plus here. Remember, A plus AN is A, n minus 1 into D is AN, is equals to A minus D, that is A2, plus this is AN minus 1, and this continues. The third term is equal to last third term. The addition of third and last third is equal to first and last. Okay, that's the concept of AP. This note I will not take it here. Okay, it can affect the consistent notes, so just remember it. Okay, I had not thought this, I have thought this now. Okay, right, that was an AP. Now we will see of GP. If I have three terms, A1, A2 and A3 are in GP, now I can take it as A by R, A and AR, A by R, A and AR. If I have 4 terms, I can take it as A by R, AR, AR cube, A by R cube. I can take like this 4 terms, right? If I want to take 5 terms, A, AR, AR square, A by R, A by R square, right? This is in the representation of, it may help you in solving the problems. Just you have to remember and apply the things. Okay, that was that thing. Next, so that was the thing of and GP. Now if A1, now if A1, A2, A3 and so on are in GP, then if I am applying log on them, log A1, log A2, log A3, this will be in AP. Remember this thing also. This will be in AP. So GP is a small concept but also a better big concept only, right? This was all about GP, the concept of GP. I'm not solving any problem in this session as it may drag the session. So okay, wait. So in GP we have general representation, nth term, sum of nth term, n terms, and product of n terms, not product of n terms. Okay, and log, if I put log it will become a GP. That also we have done, right? Now next is our harmonic progression, right? In harmonic progression it is called HP. I'll just write harmonic P, that is harmonic progression. Right, harmonic progression. It is a small concept, it is not much big as it was in AP or GP. See, if it is just reciprocal of harmonic progression is reciprocal of arithmetic progression. Harmonic progression is reciprocal of arithmetic progression. Just you can remember this thing, it is the reciprocal of arithmetic progression. Now in HP, if A1, A2, A3 and so on up to AN are in AP, then 1 by A1, comma 1 by A2, comma 1 by A3 and so on up to 1 by AN are in HP. That's it. That is the general representation of an HP. General representation of an HP. Here that will be in HP. If ABC, so I have skipped one more thing in GP also. See, in GP, see, one thing which I had skipped was in GP, if A1, A2, A1, A2, sorry, ABC I'll take. ABC are in GP, then twice the B is AC. The product of A and C is 2 times B. The product of A and C is 2 times B. This is also important question. Right. Okay, now that was about GP. Now I'll come back to HP. If A comma B comma C are in HP, if A comma B comma C are in HP, then 2 by B is equals to 1 by A plus 1 by C. These are in HP, not AP. These are in HP. Okay, remember. That is the thing here. If ABC are in HP, 2 by B is equals to 1 by A plus 1 by C. Okay, that was about HP. So HP is only this much only, not much tricky and not much rocket science concept. It is easy concept. This was about harmonic progression, right? So I'll just divide it, so one who will refer only notes, it will definitely help them. So I'll divide it like this. And this is one more concept. So thank you. If it helps, please do subscribe and like, comment your opinion on this channel. Thank you.